Alrighty, folks. Today we are going to be talking about metric measurements. So let's go ahead and get to it. All right, first things first, let's go ahead and if you haven't yet, I'd like you to go ahead and take quick quiz 1.5. Reminder that this is for attendance. Make sure the first time you're taking it, you're not using notes or help. See what you know and what you don't know. And just a reminder, you can take it as many times as you want, always keeping your highest score. So go ahead and pause this video, take the quick quiz, and then come on back. Alrighty, folks. Quick announcement. The paper, airplane, lab, and conclusion are due Friday, September 18th, which is today. So make sure that if you have not finished that, you go ahead and get that taken care of and turned in. Alrighty, so here is our note setup for today. So go ahead and set up your heading, where our topic being metric measurements. Your essential question for today is what is the relationship between length, mass, and volume in the metric system? Our learning target for today is I can accurately measure length, mass, and volume using the proper tools with appropriate metric units. Alrighty, I'd like to pose a question to you. What is the height of the table that you are sitting at? So just go ahead and take a moment and see if you can't figure that out and sketch yourself down a number, whatever it is that you have. Alrighty. So quick, interesting piece of information. The United States of America, Liberia, and Myanmar. What do these countries have in common? Well, these three countries are the only countries that use the empirical system of measurement. Sorry, that took me a second to get there. That includes things like inches, ounces, gallons. The rest of the world, here highlighted in green, they all use the metric system. So this is something that is very unique in America and in science because the rest of the world uses metric. We use metric as well. So we're going to talk about metric today. And also part of highlighting this is I am willing to bet that a lot of you, when you wrote down the height of the desk that you are sitting at, you probably wrote it in inches or feet. And that is something that we are going to try to get away from as we are working in this class. Alrighty. So, just so you know a little bit about the imperial system, go ahead and pause this video and go ahead and play the video that is on your Nearpod. This is a system, or this is a video that kind of walks you through what makes up the imperial system that we use, and you'll see how it is very logical, shall we say. So, pause this video, watch the video on Nearpod, and then come back. All right, so I hope you got all of that. You'll need to know all of those conversions for the exam. Just kidding. The imperial system is kind of ridiculous, and so we want to get used to using metric because it's a lot simpler than the imperial system of measurement. All right, so let's go ahead and start on our notes here. What is it that we are measuring? And what we are measuring is matter, and matter is the substance which all material is made of. If you are trying to figure out what is matter, basically anything that is a noun is going to be matter. The things that are, so basically if you can touch it, see it, feel it, smell it, anything like that, that is all matter. Now, can you think of anything that is not matter? A couple of things that may come to mind include things like thoughts and ideas. Those are not matter, those are abstract things. Um, Space is not matter because it is, by definition, the absence of matter. Light falls into a very weird little category where it is produced by matter and it has properties similar to matter, but it's technically not matter. Similarly, energy is not matter. And the other thing sometimes people say is antimatter. Antimatter is also technically not matter. It is the opposite of matter, but that's not something we're really going to talk about. But the vast majority of everything that you can think of is matter. What question does the previous slide answer? Go ahead and pause the video, write down your guiding question, and then continue. All right, so In order to measure matter, we are going to use the metric system. Now, the metric system is a series of measurements based on tens, as opposed to the incredible number of different ways to convert in the imperial system. All metric measurements are based on tens. And in reality, much of the metric system is based around water. If you take a cube of water that is 1 centimeter on each side, that is going to be 1 milliliter of water, and 1 milliliter of water has a mass of 1 gram. So that's kind of where a lot of the basis of the metric system comes from. It is used throughout the world except for us, more or less. The metric system is just a very much more straightforward way of thinking about measurement. So I want you to go ahead and turn to this page in your notes, and let's go ahead and talk about the different tools that we use to measure. So this is what we're looking at here. All right, let's start off by looking at the definitions of different measurements. So first off, mass is going to be the amount of matter in an object. This is going to be related to kind of how many atoms are in an object, which ultimately then tells us the amount of matter in that object. Length, this is going to be the distance between two ends of an object. We're actually going to be using length and distance a lot in the upcoming unit. Finally, volume is the amount of space that an object takes up. And actually, this is pretty closely related to length, because in order to figure out space, you just use length or distance in 3 dimensions. So right here, this is a scale, and a scale is what we use to measure mass. Our base unit for mass is going to be grams, and the symbol that we use for grams is G. So if something is 10 grams, you would write 10G. Right here, this is a meter stick, and it measures distance. Our base unit is meters, or M. You might be more familiar with centimeters, but that is actually a broken, or that is a a broken down version of meters, and we'll talk about that in just a second. The actual base is meters. This right here is called a graduated cylinder. Unfortunately, until we are back in the classroom, we're not really going to use graduated cylinders, but I do want you to be aware of them. They are what we use to measure volume. The base unit for volume is liters, and we use L for that. Now, the nice part about the metric system is I just gave you the 3 base units, and each of those is equal to 1 of itself. So 1 gram, 1 meter, 1 liter. However, we can use prefixes. So this is a part of a word that comes at the beginning of the word to tell us something about that word. So what this means is we can take the word kilo and put it in front of the word meter, and that is going to result in a kilometer, which has a value of 1,000 meters. So it's kind of a shorthand way. Instead of saying something is 1,000 meters, we can say that it is 1 kilometer. So we have a few of these that we need to know. H is hecto. We symbolize that with H. The value is 100, and so a hectoliter would be 100 liters. Deca, the symbol for the prefix is dk. The value of that is 10, so a decagram would be 10 grams. You would write that as dkg for the symbol. Base unit, we've already talked about. Now, you can also divide base units into smaller parts. So a deci, symbolized with a D, is 1/10 of a base unit. And so a decigram would be 1/10 of a gram. You would need 10 decigrams to make 1 gram. Centi is C. It is 1/100th of a base unit. And a centimeter, you need 100 centimeters to make up 1 meter. Milli is M. It is 1/1000th of a base unit. And milliliter or milliliter is going to be 1/1000th of a liter. You need 1,000 milliliters to make up a liter. So make sure you have all of this filled out. We're going to talk a lot more about this table tomorrow. All right, what question do the previous slides answer? Pause the video and add a guiding question. All right, last thing we're going to talk about is accuracy and precision. These are really important terms in science, and a lot of people might think accuracy and precision, those are the same thing. They are related, but they are not the same. Accuracy is how close measurements are to the true value. So if you're thinking about playing darts, accuracy would be hitting as closely to the bullseye as possible. That is your target, and you're trying to hit in the middle there. So accuracy is trying to hit that. Precision. This is how close repeated measurements are to each other. So if you were to throw 3 darts here at this board right here, that would be precise, okay? So if you think about it, would you rather be able to, or if you were playing darts and you were picking a partner and you had someone throw, and you had 2 people, one person threw a dart right on the bullseye, but then threw a dart out here and out here. Whereas the other person, they throw 3 darts and they hit all 3 darts, 1, 2, 3, in this little 9 section right here. The question is, who would you want to be your partner? Now, some of you might think, well, the first guy, he hit a bullseye, so I want him. But the thing is, his other 2 darts went off the board. So he may have had an accurate throw, but he was not very precise. Whereas the second player, she hit all 3 darts in a very tight little circle here. So even though she wasn't accurate, she was precise. She can put the darts in the same spot. So all this person needs to do in order to improve is move where they are aiming, and then they'll be able to hit bullseyes. So precision is actually more important, because once you have precision down, then you can get accuracy. Let's go ahead and take a look at what this means in a little bit better terms. If you turn in your packet, you will find a chart that looks like this with a bunch of targets on it. And you can imagine this as an XY axis. And so on the Y axis, this up-down axis, we have more accurate on top and we have less accurate on bottom. On the X axis, the left to right axis, we have precision. On the left, you have less precise, and on the right, you have more precise. So we are going to show what the difference is between accuracy and precision. First off, on this bottom left, this is a non-accurate, non-precise throwing of darts or making of measurements. So in this case, we have, go ahead and put marks where these 3 blue dots are. And this is not precise because the marks are all far apart from each other, and it is not accurate because none of them are close to the bullseye. If it is more precise but less accurate, then we would have all 3 marks right here. So go ahead and put 3 marks really close to each other like this, but away from the bullseye. So in this case, we're precise because the marks are all really close to each other, but they are not on the target. Up here, we have a more accurate but less precise bullseye. So in this case, we had a bunch of marks hit the target, or the bullseye, which is good, but they aren't necessarily that close to each other. So that would be something that is more accurate but less precise. Whereas right here, this is what we're ultimately going for. More accurate, so you're hitting the bullseye, and more precise. All the marks are very close to each other. So what we're looking at here is if you have precision like this, it's much easier to move your measurement or move your aim and hit the bullseye, because then all of your targets will, and all of your marks or measurements will be accurate. You just have to change that, how you're measuring. So if we're thinking about this in terms of measurements, let's say that we are measuring the mass of something. What we want is if each time we put an object on the scale, we want to get the same mass. If the correct mass is 5 grams, we want to get 5 grams every single time we measure that object, okay? If we measure that object and we get 10 grams each time, we know that the scale is precise, but there's just something wrong. We can adjust the scale and we can get closer to, or we can get it to read 5 grams. Whereas if every time you put that object on a scale, you're getting 10 grams, 2 grams, 12 grams, that's not going to be particularly helpful. That does, because then you're not accurate, nor are you precise. So we're going for precision and accuracy. All right, what question do you have about or what question do the previous slides answer? Go ahead and fill that out right here. All right, so now that we've talked about this, what is the height of the table you're sitting at in metric units? So think about it. Maybe you ballparked the number in feet earlier, but now let's return to this. If you have a ruler near you, see if you can't measure what the actual height is in metric units. and see if you can measure it a couple of times and get your answers to line up every single time, because then you have an accurate and precise metric measurement, and that is ultimately what we are going for. Alrighty, folks, go ahead and pause the video, take the quiz, and then we will talk about the answers. All right, which are examples of a metric unit? Select all that apply. Millimeter and gram are both metric units. Foot is going to be a imperial unit. Centi, while that is a metric prefix, ounce is an imperial unit. The amount of matter in an object, that is going to be the mass of an object. So when we are measuring mass, we are figuring out how much matter is in that object. Length is going to be the distance of an object, and volume is how much space that object takes up. The cluster of marks here are, these are all clustered close together, but far away from the bullseye. So that means they are precise, but not accurate. All right, so if you answered those, you should have gotten 100%. All right, folks, if you have any questions about today's material, go ahead and post in the Schoology discussion. And a quick poll on a scale of 1 to 5, how well do you understand metric measurements? Now that we're wrapping up here, I got two things that I want you to do to finish the day. First off, head back to our Schoology folder, and in there you are going to see a demo called Measurements in Cooking. It's a short video I'd like you to watch that I made where I show you how all of the different measurements work, specifically when you are doing a recipe. So go ahead and check that out. And then finally, I have a Flipgrid posted about metric measurements. I would like you to do a very quick video showing me you making 2 metric measurements of some kind. And maybe you don't have the exact tools, and maybe you have to estimate, and that's fine. But go ahead and show me 2 metric measurements that you make, and make sure to include your name.